Okay, welcome everybody. Welcome to the APEC virtual conference. It's too bad that this conference is not live. We were all looking forward to seeing everybody. It's unfortunate with the virus, which is unexpected, come not in the US, but everywhere in the world. Hope you are having a safe and wonderful stay and at home or wherever you are. Um, so I was actually all looking forward to meeting everybody, and I'm sure all of you are looking forward to meeting your other colleagues from other countries in the world. So this is not the best of the thing, but I think in the event of safety, good health, this is probably the best thing to do under the circumstances. But in any event, I'm looking forward to seeing you at the next event, and hopefully you'll have a wonderful virtual conference. Um, and it was wonderful to have you in the class. I hope you enjoyed my talks, lectures, and so on. And I'm looking forward to seeing each and every one of you at the next event. So in the course, we talked about the energy, so I'm going to emphasize the energy issue. And just to give a flavor to where we are, we didn't talk too much about the energy. We talked about other few bullet point key thing, what's important, what is not important. So as you know, that the population on this planet is on the rise, right? So we have about 7.7, 7.8 billion inhabitants on the planet. And if you look at the distribution, more than 6 billion are living in the developed countries. And that's a lot. So that means that only a small fraction is in the developed countries. And if you look at the how many people are with adequate energy, or how much of the social development in these countries, you'll be surprised to see that roughly about 1.6 billion people are without electricity. So that's about 20% of the population on this planet, they're without electricity. So just imagine what you could do or what you could not do if you didn't have the electric power. So as you all experienced during the recent time, energy is very important. Even your own energy is very important. If you have energy, you can do anything during the day. If you don't have energy, you feel sick, you can't do anything. So same thing goes for the internal and the other available energy to you. So we need the energy supply of energy because it's all the development, complex societies which you develop, it's all based on the energy. So energy is really the key pivotal issue. Doesn't matter where you go, what you do, how you feel, whether it's your own energy, whether you borrow the energy to do something which you want to. So we need to have some kind of life cycle approach to assess what the technology is in the system, because when you use the energy, you leave a trace behind. For example, you might have noticed in your own country that these days, because of lack of driving, lack of activity, lack of industrial activity, you see clear skies. Maybe not as much as in some places, but there's certainly here in the United States where I am, I see a distinct difference. You get up in the morning, it's just deep blue sky, which I've never seen before. Even the trees look very greener because they're not bombarded with the pollution around you. So when we think of the life cycle approach, we need to think of what the footprint we're going to leave it. So in a way, you can think of the environmental impact is very important. And what you can do as an engineer or future engineer, future decision maker, to improve the efficiency and reduce the print. So in order to make that happen, we need to use and make it into our common domain energy supply from all kind of different sources. So you don't need to think of oil, gas, and coal as the main source of energy, because each one has a different use, and each one different applications. So we need to think of what the other forms of energy we can use here. So here's the demand on the energy. And basically it tells you where we were almost 20, 30 years ago, and what the projections are for the next 20, 25 years. So you can see that renewable energy is on the rise, and so is every other form of energy. But one distinct difference is that the coal is not going to be used as much compared to what it has been over the last millennium. So if you look at around 1990, 2000 timeframe, you can see the increase in coal was tremendous because of the tremendous need for the power growth. On the other hand, if you look at the liquid fuel, they're very important for the transportation sector. So basically, where's that going to come from is really what we should think of. And if you look at the coal was the traditional form, and the clean power plant is the one which, with the clean power plant, of course, the environment is much more cleaner than what you would do otherwise. So we need to think of the emissions. Emissions are just the few examples which are shown here. Contrails, which is basically a small cloud which came in, gave the shadow, and so on. That only lasts for a few hours, few minutes, few hours. And if you look at the other emissions, like the NOx ozone emission, that lasts from days to weeks. And if you look at the methane gas, that lasts over the period of years. And if you look at the carbon dioxide, we're talking about several decades or centuries. So basically what that means is that any carbon, when used as an energy source, we're going to leave behind a CO2 as the trail gas, and that's going to last for a long, long time. It's even beyond when we are all gone. So we need to think of, when we talk about the centuries, what the impact is going to be. So of course, the CO2 has been rising, as you've seen it, and now the global rise in CO2 concentration is the highest ever. And the rate of increase is roughly about 2 ppm. And it's not stopping, it keeps on rising. So we need to think of what do we do about CO2 is a greenhouse gas, and so is the methane and many other gases, the greenhouse gas. Water vapor does cause some impact, but water is clean, so we're not going to talk about the clean water vapor. So when we look at the energy, as I talked about the coal, so coal is a good source of energy. We need to have a clean source of fuel. And if you look at the usage in China, you've seen it that over the last few years, it's been on the decline. But before that, before 2010, or even the last part of the last millennium, there was a tremendous boost increase in China because everybody wants energy. And if you need energy, it needs to come from somewhere. And coal is a very good source of energy, available in large quantities, not in China or the United States, but also in India and other countries. So coal is a very useful source of energy. But the problem is the CO2, which is carbon rich in coal, that gives you. So you can see here the exploded view of what the United States had done with the clean power plant. So the clean power plant, the actual usage and actual emissions are lower and projected to be lower as we look at down the line here. So the type of coal which you can use is large variety, bituminous, subbituminous, anthracite, and many other kinds of coal. But the basic thing about the coal is the carbon dioxide emission is roughly about twice as much compared to what you get for the natural gas. So on the left-hand side, you see the different types of fuel, fossil fuel, which we have, which is basically coal, oil, and natural gas. And when we want to use this, you need some kind of storage, transmission, you need the other forms of energy. And of course, nuclear is one, but the question is, what do we do with the nuclear waste? So the top three items are the fossil fuel, and storage is a must. And it turns out that the natural gas, coal, oil, we have a good source of storage. Physically you can store it. On the right-hand side, what you see is the different types of renewable energy, hydro, wind, solar, geothermal, and hydrogen, of course, is a man-made. In other words, you make it from source A, it's converted to source B. It could be from biomass, it could be from fossil fuel, it could be from solar, PV, and the other thing. But it's a man-made, right? But it's a beautiful fuel because it doesn't give you anything other than just water vapor. And water vapor, we need a good, clean water anyway. And then, of course, there are other types of fuel which are there, which is the wind, offshore wind, onshore wind, and sea weeds, farms which are there. And so that can be used as a good source of energy. And the reason I'm bringing up the seaweed is because if you look at the 2/3 of the area on this planet, that's actually sea. So if we have some seaweed which is available and that can be used as a biomass, that's a great source of energy and that can last for a long time. But we can talk all this, but the key thing is there's the whole bunch of energies which are there and they are at our disposal to use it. So the key to sustainability is to really use a mix of things because not every fuel is usable for every purpose. For example, if I take a biomass, you cannot use that for the transportation sector. That's a great source for in a small industry and so on. And the biomass need to be at the location where it's grown. If it's a long haul, that means you're using all the energy to haul the biomass from A to B. So these are the scenarios which are available to make it available and on a given form what you need it for. It's really where the engineers can provide a big role. So what I'm talking about here is we need the inexpensive energy, low cost energy, and there's all kind of availability available to you. And this I'm talking about the near-term solution for the next 100, 200, 300 years, not 1,000 years from now, because who knows what will happen in 1,000 years. So in a way, there's no silver bullet, I can say that this is available to you, but these are the scenarios which are available. So biomass is actually picked up as an example. It's very important fuel. And the reason being that the biomass grows, so we take the CO2, although the conversion is very slow, it takes roughly about 40 years to get 1 ton of CO2 converted into biomass. So very slow. And if you look at the human being, we actually emit many times more CO2 than what the biomass can take it. But yet when we look at the industry, which takes these fuel and convert that to CO2, this is several orders of magnitude larger. So the key thing here is the biomass, you can take it, you can use that in industrial applications, for example, make into wood chips and make that a wood pellet, so we define composition, and switchgrass, which is very rapidly growing biomass. And you can take all this on corn leftover, corn store, and corn cobs, and so on, all that biomass, or even the municipal solid waste, which you generate quite a bit. In every country, we had the solid waste disposal. So you can actually convert that into fuel of desirable form. And given here in the bottom left-hand corner is the oils which you can generate either from the biomass or even the waste cooking oil, you can convert that to fuel. So the important thing about the biomass is something which is in your hand. It's just like education. When you graduate, you had the knowledge which nobody can take it away. So same thing here, biomass is something which is available to you and you can convert from A to B for a given application. For example, biomass, you can convert that to liquid fuel and you can use that for transportation sector. So very, very important element. Not to say that the other forms of energy are not useful. So I just picked up one example, which is very important. So here I give the example of where we are, energy demand in 10, 15 years ago, and to where we're really heading to. In other words, another 10 years from now, how much it will be. So you can see the United States will see an increase of about 10%. And if you look at the wood energy use, we will see an increase of roughly about 45%. These are the projections taken from reliable sources to see where we are. So fossil fuel is continue to be dominant in terms of supply and usage, which you see it here. So renewable energy, for example, right now is about 13% and in the worldwide, and it's expected to perhaps go 1 or 2% more. Because remember, it's the quantity which you're talking about here. So US uses roughly about 100 quarts of energy, 100 times 10 to the 15 BTU per year. and 85% energy is from the fossil energy. And if you look at the worldwide, it's not 85%, but 81% is fossil energy, and the rest is renewable. So renewable energy provides a finite amount of source, but it cannot be 100% renewable because something is either not in the infrastructure, or we don't have the developed technology for use it for the various applications. Sure, you can use it in a small community, small area to make it 100% renewable, but how do you make that at a large scale, especially when we're thinking of 400 to 500 quadrillion BTU per year of energy use, and projected to go to about 600, 700 quadrillion BTU of energy per year. So it's just the large scale magnitude which is there, which is really frightening some. So if you look at the nuclear, it's a good source of energy, which doesn't produce any CO2. But the problem is, how do we ensure that it's safe, secure, and robust, reliable, not having unwanted issues like we saw in Fukushima a few years ago. So fossil fuel are expected to stay in the main domain for large scale usage of the energy. But on the other hand, when you look at the renewable energy, I think we are slowly on the rise, especially when you look at the wind energy, onshore, offshore energy. That's a very good source of energy. So you produce the electricity, and once you have the electricity, now the question is, how do we store it? So that's a whole different challenge, which as you go along, we'll see this here. So in order to have the sustainability, we need to have many of the key issues, which is we need to have the energy needs for the future needs without compromising the ability to do what we want to do in the future needs, as well as the future generation, what they will want to do. So there are different definitions which are put it over here. So the idea is to really have the energy availability so that we can do future needs as we want to do our function and keep growing with the youth. So energy is going to be very, very important. Availability for the future generation is going to be very active, and the needs need to be met for all citizens, all habitants on this planet, because that's really is the most important. You, as the future youths of your country and the world economic growth, have a substantial role to play. And I think this is something which you can think of what we learn in the classroom. And this is something which I think you can focus on and make a great deal of impact in the society, which you can pass on to live along. So it's almost the time to think of where you'll go next. Here's the map of the United States, and I'm giving a red dot on the right-hand side. It gives the University of Maryland. That's where I am. And you can see that the top 25 programs in the computer science, maths, physics, and engineering, if you look at all the programs, you can see that there are very few schools which are in the top 25. Of course, the MIT, Harvard, that's in the Northeast or in the top. Princeton is right there. But if you look at below Princeton in the whole Northeast section of the United States, University of Maryland is amongst the top 16 in the engineering program, and many other programs which are actually in the top 20. And that number is about 68, 69 program. So you may want to consider University of Maryland as your future learning activity, and I'm always there to help in any way I can. If you need me, I'm just electrons away, emails away to contact me. So this is just a picture of the University of Maryland. You can see at the bottom left-hand corner, this is where the University of Maryland started. This is in the early more than 150 years ago. Basically, the classroom was downstairs, only a few students, and living quarters on the top. And we have a beautiful campus. You can see on the top left-hand picture, which is the Glenn Martin Institute, very popular one, very prestigious. And on the middle picture here, you see beautiful flowers. These are the cherry blossom. In Japan, they call it sakura. And sakura was actually given by the president of Japan to the United States some 90 years ago. And you can see that our cherry blossom festival, which is sometime in April, is just as good, if not better, than what we've seen in Japan. So you will see that for real. I'm in the H. Ames Class School of Engineering, Department of Mechanical Engineering. So if anything I can do, I'm just email away. With this, I'll thank you all. Have a great, wonderful day, and wish you all a very fruitful and productive meeting. Again, it's too bad that we were not able to meet in person, but I'm really looking forward to hopefully next year to see you all at the event. Have a wonderful day.